All right, so in the last video, we looked at how to graph log functions. So in this video, we're quickly going to look at how to do transformations of log functions. So let's go ahead and let's do an example. And we are just going to use transformations. To graph the function. All right, so let's say we have the function g of x is equal to, let's go with the log base 2 of the quantity x plus 3 plus 4. Okay, so this is our function that we're going to be trying to graph. So just like any other time we're looking at transformations, we need to start by identifying our parent function. So you're basically thinking about take off anything that looks like a transformation. So the plus 3 is a transformation, the plus 4 is a transformation, and what we're left with as our parent function is just the log base 2 of x. Okay, so a log function with a base of 2. All right, so then we need to list out our transformations. And of course, just like we've always done in the past, we have to think about anything inside the parentheses affecting our graph horizontally and anything outside the parentheses affecting our graph vertically. So inside our parentheses, we have this plus 3. So that is going to give us a shift left 3. And then outside our parentheses, we have the plus 4, so that's going to shift our graph up 4. Okay, so let's go ahead and make a quick table so that we can graph this function. Now with transformations, I'm always a little bit lazy on my table. I don't want to have a ton of points that I need to graph because we're really just looking for a general shape of how do the transformations change the parent function. So we want to make sure we have a couple points on there, 2 or 3 is sufficient, and make sure that our asymptote's in the right spot. And actually, speaking of the asymptote, let's think about real quick where our asymptote's going to move to. So remember what we talked about in the last video, that for any basic log function, no matter what the base is, so whether we had a base of 3 or we had a base of a half, we always have this vertical asymptote at x equals 0 on any of these parent functions for logs. So if we're taking our graph and we're shifting it 3 units to the left, that's going to take that vertical asymptote at 0 and shift it 3 units to the left as well. So this is going to move our vertical asymptote to x equals 3. Okay. The shift up 4 doesn't affect our asymptote because think if you have a vertical line and you move it up, nothing changes. It's still the same vertical line. So it's just the horizontal transformations that will affect our vertical asymptote for log functions. Okay, so now let's go ahead and get these points. So we're going to start with our parent function like we usually do. And remember, for logs, we're thinking of these as the inverse of an exponential function. So inverses, we switch our x's and y's, okay? So I'm going to go ahead and I'm going to pick any y values I want to, really. I'm just going to go with 0 and 1, okay? Those are usually good y's to pick when you're graphing one of these transformations. 0 is nice because it's your intercept point. That's always helpful to have. And then 1's just a nice number, okay? All right, so then, again, we're constructing this table backwards because it's a log function and that's an inverse. So for my x's, I'm going to think about my base, which is a 2 on this one. And I'm just going to do 2 to the power of 0, which, remember, anything to the power of 0 is 1. And then 2 to the power of 1, which is equal to 2. Okay. All right, so we're using the base and raising it to different numbers that we want, and that exponent is our y coordinate. All right, and you're welcome to use more points if you want to, but 2 or 3 is enough for these. Okay. All right, so then I'm going to add in my transformations. So we're going left 3 and up 4. So left 3, I'm going to take my x's and move them to the left. So that'd be subtracting. So we'd get a -2 and a -1. Up 4, I'm taking my y's and moving them up. So that'd be a 4 and a 5. All right, so these would be our new points. The left 3 would be our new x that we're going to plot, and the up 4 is our new y that we're going to plot. All right, so let's go ahead and graph this function. All right, label your axes as always. Okay, so we said our vertical asymptote is at, oh, I'm sorry, I wrote that wrong. I apologize, guys. We were moving 3 units to the left, so that should have been x equals -3. My bad. All right, so our vertical asymptote is at x equals -3. Sorry if I confused you on that one. Okay, and then we have our points here at -2, 4. Oops, I didn't make this go high enough. So -2, 4, and then -1, 5. Okay. All right, so if we connect our points and we approach that vertical asymptote over on the left-hand side, we will get something like that as our graph. Okay, and it has that characteristic log shape. This, of course, is logarithmic growth because it's increasing from left to right. We have that vertical asymptote on the side, and then it's just increasing off in the other direction. Okay. All right, lastly, I want to list out my domain and range for this. So domain, reading our graph from left to right, would start at the vertical asymptote of -3 and go off to infinity. And then range, reading our graph from bottom to top, is just going to be all real numbers. Okay. Every single log function, regardless of whether you have transformations or not, will always have the same range of all real numbers. All right, if you guys want to see another example of these transformations with log functions, there is a second one worked out in the notes, but we're going to leave the video there. As usual, work on your labs, work on your homework, and feel free to email me if you have any questions on this stuff.